Cybersecurity in the industrial environment. Protection of the OT area. Bastioned facilities. Switching. The shared network is a basic network. To provide devices with greater security against intruders, switched networks or VLANs can be created using switching techniques. In the context of industrial networks, a shared network refers to a communication network in which multiple industrial devices share the same network resources, such as the same network segment or communication channel, to exchange data and control industrial processes. Shared industrial networks are commonly used in industrial automation environments, such as manufacturing plants, power plants, and process control centers, where real-time data exchange is required between different industrial devices, such as sensors, actuators, and programmable logic controllers, PLCs. Shared industrial networks can be wired or wireless and use different communication protocols, such as Ethernet, Profibus, Modbus, and others. As with shared networks in general, network congestion can be a problem in shared industrial networks, and measures can be taken to manage network traffic and improve performance. In shared industrial networks, data transmission takes place over a common communication channel, which can be a cable or a wireless signal. And all devices connected to the network share network resources such as bandwidth and data transmission capacity. One of the advantages of shared industrial networks is that they allow for greater flexibility in network configuration and allow multiple devices and equipment to be connected to the same network, making it easier to integrate and control industrial processes. However, a disadvantage of shared networks is that they can be more prone to network congestion, especially in industrial environments where real-time data exchange is required and a large number of devices are used. To avoid congestion and ensure optimal network performance, different strategies can be used, such as network segmentation, use of efficient communication protocols, and network traffic management. In addition, network security is a critical aspect in shared industrial networks, as industrial processes can be vulnerable to cyber attacks. Therefore, it is important to use appropriate security measures, such as authentication and data encryption, to protect the network and the devices connected to it. Switching is a technique used in Ethernet networks to connect devices on a local area network, LAN, and allow data transfer between them. As seen above, a switch is a network device that acts as a centralized connection point between devices on a LAN. When a device on the LAN sends a data packet to another device on the same LAN, the switch is responsible for routing the packet to the destination device. The switch uses a MAC address table to determine the location of devices on the LAN and routes the data packets through the appropriate ports. Switches can be managed or unmanaged. Unmanaged switches are simpler and less expensive, and are commonly used in home networks and small industrial installations. Managed switches are more complex and offer more features and configuration options, and are commonly used in larger scale networks. In addition to basic switching, switches can offer other functions such as virtual network segmentation, VLAN, link aggregation, quality of service, costs, and security. Virtual network segmentation, VLAN, allows groups of devices to be created on a LAN that communicate with each other as if they were on the same physical network, even though they are actually connected to different switches and ports. This can improve network security and efficiency. Link aggregation allows multiple network connections to be combined into a single, higher bandwidth, higher speed channel. This can improve network performance and redundancy. There are different standards for link aggregation in industrial networks, such as Ether Channel or Link Aggregation Control Protocol, LACP, which allow multiple Ethernet links to be combined into a single, high-speed logical channel. It is important to note that link aggregation does not guarantee an increase in data transmission speed on a network, but rather allows for better utilization of available bandwidth and increased network reliability. Quality of service in industrial networks is essential to ensure the continuity of critical processes and the safety of workers and machinery. For example, in a production plant, costs may be required to ensure that process control and monitoring data is transmitted with priority over non-critical building temperature monitoring data. Implementing costs in an industrial network involves defining prioritization and bandwidth limiting policies for different types of traffic on the network. To do so, different mechanisms and techniques are used, such as traffic classification, priority assignment, and bandwidth limiting. Some industrial network protocols, such as PROFINET or Ethernet, IP, include built-in cost mechanisms to prioritize critical data traffic and ensure real-time transmission of data. Security in switching includes features such as user authentication and flood prevention, which helps protect the network against malicious attacks and ensure the integrity and privacy of transmitted data. VLAN stands for Virtual Local Area Network and refers to the logical segmentation of a physical network into multiple virtual networks. That is, VLANs allow a set of devices to be grouped into a logical network separate from other devices on the same physical network. Segmenting a network using VLANs can provide several benefits, including increased security. By isolating different groups of devices, the risk of a compromised device affecting other devices on the network is reduced. Increased efficiency. Traffic on each VLAN can be controlled individually, allowing for better utilization of network resources. Increased flexibility. VLANs can be created to suit different needs, such as specific departments, projects, or applications. To configure a VLAN, a switch that supports this functionality is required. Switches may have different ways of creating and configuring VLANs, but in general, configuration involves the following steps. Creating the VLAN. A VLAN must be created with a unique ID number and a descriptive name. Assign ports. Switch ports must be assigned to the appropriate VLAN. Ports can be assigned to a single VLAN or to several different VLANs. Configure VLAN trunking. If multiple switches need to be connected together to support multiple VLANs, VLAN trunking needs to be configured to allow VLANs to communicate between switches. Configure other options. Additional options can be configured, such as inter-VLAN routing, security, and quality of service, costs. In addition to the benefits mentioned above, VLANs can help reduce network congestion by grouping devices into separate logical networks. For example, if a department has a large number of devices that generate a lot of network traffic, a separate VLAN can be created for those devices, which reduces traffic on the main network and improves overall network performance. Another advantage of VLANs is that they allow for greater flexibility in network organization. For example, if a new department or team joins an organization, A new VLAN can be created for that group without needing to reconfigure the entire physical network. This can be especially useful in companies that experience rapid growth or frequent changes in organizational structure. To manage a network that uses VLANs, it is necessary to understand the different types of switch ports that can be present in a VLAN. The two main types are access ports and trunk ports. Access ports are those that are directly connected to an end device, such as a computer or IP phone, and are assigned to a single VLAN. Trunk ports, on the other hand, are designed to carry multiple VLANs over a single connection and are configured to allow traffic from all VLANs. Lastly, it is important to note that VLAN configuration must be carefully planned to ensure that network security, efficiency, and flexibility goals are met. Poor VLAN configuration can have negative effects on network quality and may introduce new security issues.